Chapter 3, Number 41. To visit your favorite ice cream shop, you must travel 490 meters west on Main Street and then 950 meters south on Division Street. A. Find the total distance you traveled. B. Write your displacement vector in unit vector notation using x hat to be east and y hat to be north. And then C. Write the displacement vector which will be required to return to your starting point in unit vector notation. So we start off at the corner of somewhere, and we travel 490 meters west, and then 950 meters south. And we're looking for this thing, which I'm going to call vector R. That's vector R. And we want to find the total distance and then write out vector R in unit notation. So the total distance is relatively easy. It's the square root of 490 meters squared plus 950 meters squared. All of it square rooted, as said, and we get 1,070 meters to the proper sig figs. And that's part A. And then part B says write R in unit vector notation, but that's actually really straightforward because unit vector R here is going to be 490 meters west, which is minus x hat, and then 950 meters south, which is minus y hat, and that's just based on the definition they gave us for x hat and y hat. It would be more usual to write this as minus 490 meters x hat minus 950 meters y hat, but that's optional. Both of those are basically the same statement. And then finally, what is the displacement vector that gets you back to your starting point? So if we say we want to look at this and we want to go from here to here, very clearly what we're looking for, which I guess I'll call S vector, is that S vector is just minus R vector. And the nice thing is that we can just treat this algebraically. So it's minus, and then in parentheses we'd have minus 490 meters x hat plus minus 950 meters y hat, and then I can just distribute the minus, which cancels out in both cases, and I get 490 meters x hat and 950 meters y hat.